Hello team, this is going to talk about software engineering. So in an ideal world, software engineering would go like this. We would identify the need for a new piece of software, then we would design and implement that code, maybe test it, and then put it to work. And then users would just run that software that solves that specific problem indefinitely, forever. So this would be great, but it doesn't work for all but the simplest pieces of software. And there are many reasons why this write once, use indefinitely approach doesn't work. So one of them is that operating systems and frameworks evolve over time. So operating systems have to evolve, for example, to support new hardware or support new functionality, and same thing with frameworks. So I maintain a website that we built using Django back when Django was version 1, and then we had to upgrade it to version 2. We just upgraded it to Django 3, and now it's already outdated because Django 4 just came out, so I have to upgrade the website again. So each of these upgrades requires some change to the code. Another problem is that if a software is complex enough, you can test it, thoroughly, but it might still have bugs in it. So these errors will be found eventually, and they will require fixing. And finally, users might ask additional functionality or extensions to the software that was initially built. So let's take terminal emulators as an example. So here is a screenshot of Xterm. And Xterm has been around for like decades. And you might think that terminal emulators might be complete by now. We would be done with fixing terminal emulators and everyone would be happy. But this is far from the truth because people keep asking more functionalities from terminal emulators. So these days we have terminal emulators that can play video and show any colors. I mean, there's a lot of innovation in terminal emulators these days, as funny as it sounds. So here we have a screenshot of Kitty running some video at 128 frames per second. So in practice, the software development cycle looks more or less like this. So we have some requirements, and then we might design a software, build and test it, and then we deploy this software, for example, on the cloud or on a private cloud or as an installable that people install on their machines. And then finally, users will, make use of that software. But it doesn't end here. So users might find bugs or environment where the users are using the software might change, say the operating system was upgraded or the frameworks need upgrading. So the software will need updates and bug fixes. And also users might request more functionality or extensions, and then we might go back all the way to the requirements phase and see how we're going to develop this new functionality and then go through the process again. So there are different software engineering approaches like extreme programming, Scrum, and Agile methods. And one of the things that differs between them is how frequently they iterate over this cycle. The software engineering approach I studied when I was an undergrad had a lengthy requirements phase where we would study what the client wanted and then design the solution. Then we would build and test the whole thing in advance and then ship it to the client. And this, changed in recent years because this approach incurs a lot of risk. If you finish building something that's not what the client wants, then you need to go back and build something else. And it might be the case that the user doesn't know what it wants in advance. So these days, the agile methodologies, they identify the requirements, but they don't go through a very lengthy process. They identify, high-level requirements and then start building immediately and try to ship something to the client sooner so that the client can see what's being built and provide feedback, and then they can iterate while the software is being built. And this is one of the shifts that we have seen in recent years. So instead of building the whole thing and shipping it all at once, we now build small pieces and ship it frequently to the client to get feedback more frequently. Now, when we have a project to build a large piece of complex software, then we will likely use multiple teams. And 3 teams are very common. One is the development team, which takes care of designing the software and implementing it. Then we have a quality assurance team or the testing team, which is in charge of making sure that the code works and that it satisfies the requirements. And then we have an operations team that will run the software. And then the clients will use the software, and the operations team will make sure that the software is available at all times. So the development team implements new features and writes bug fixes and sends the software to the quality assurance team. So the quality assurance team will test it and evaluate, and it might identify defects. And when the quality assurance team identifies defects, it will send these defects to the development team, which will address them, like write bug fixes or change something in the code. And when we have iterated enough on this, testing phase, then the quality assurance team might deem that the software is okay to be deployed and send it to the operations team. And the operations team will deploy the software and the users will start using that software. Of course, when the software is being used, we might identify new defects that the quality assurance team didn't identify. We might identify incompatibilities with the environment where the software is being deployed, or the users might ask for extensions or new features. And then we go back to the development team to implement these new features and fixes. And this is how the teams interact in the different steps of the software development process. So the development team is mostly involved in the requirements and building of the software. The quality assurance team is involved in this testing phase, and then we iterate in testing and updates to fix the defects. And then when we release the software, operations team handle the deployment and support so that the software is available to users. So this approach works, but it has a problem in that the teams have conflicting interests. So here I've drawn the quality assurance team a little bit closer to the operations team because their interests are better aligned and their interests conflict with the interests of the development team. So the development team wants to ship more features. They want to ship features yesterday, like super fast. They want to use the latest and best libraries and frameworks that are available, and they want unlimited compute resources. On the other side, we have the operations team and the quality assurance team. They want to use stable libraries and frameworks so that the environment doesn't change as often. They want lightweight code that use few resources, and they want zero errors so that the users don't complain and so that they don't have to address errors midnight or Sunday morning. So these conflicting interests can be worked around, but they're there. And this is one of the things that DevOps tries to address. So let's talk about DevOps in the next video.